So let's continue from where we left off, which is in question 21. Okay, so diagram 21 shows Jamil driving a bike, okay, at a constant speed of 25 meters per second. Now, of course, the key word here is the word constant speed. Okay, whenever we say the word constant speed, we're talking about zero acceleration. Okay, these two must always come together. They will not tell you secara terang benderang bahawa ini adalah zero acceleration. You are supposed to understand that if something is traveling at a constant speed, okay, dia punya kelajuan adalah tetap. That means it is not accelerating. Dia bukan bertambah laju. Acceleration happens when kelajuan itu bertambah atau kelajuan itu berkurang. Tapi sekarang kamu punya kelajuan adalah constant. You have a constant speed, so it must be zero acceleration. And when we're talking about zero acceleration, okay, it also means that the net force, okay, is zero. Okay, and when we say the net force is zero, means all the forces forward and all the forces backward, okay, F1 plus F2 equals to 0. Okay, so all these things come from the word constant speed, which we are required to understand. Okay, now dia bagi tahu the two forces resisting the motion are air friction of 30 newtons. So the air friction is backwards 30 newtons. Frictional force is 80 newtons. Okay, so find the thrust force of the engine. Okay, and so as I said just now, if F1 plus F2 is equals to 0, okay, since F2 is negative 110 newtons, sebab dia ke belakang, okay, so that means the F1, the thrust forward must be also 110 newtons. Okay, so this kind of question is very normal, okay, to be asked. They will always give you a speed, okay, a halaju yang sebenarnya kamu langsung tidak pakai pun. Okay, you are actually just made to understand that the constant speed equals to zero acceleration, which means that the net force is equals to 0. Next question. Okay, diagram 22 shows a woman pushing a lawnmower at uniform velocity. Okay, the same thing. We have the same words again, uniform velocity. So calculate the pushing force on the lawnmower if the magnitude of the horizontal component is 85 newtons. That means it's here. We are talking about this F. Okay, and it's saying that the horizontal component sini adalah 85 newtons. Okay, so we have to talk about the resolution of forces lah. Okay, so let's talk about the resolution of forces now. Okay, so any sengit force lah, okay, any force that is given at an angle, okay, of theta, okay, can be divided, or dia adalah sebenarnya gabungan, okay, two perpendicular forces, okay, which is one is horizontal and one is vertical. Always. Okay, any sengit force kamu boleh pecahkan kepada gabungan dua daya yang saling bertindak at the same time lah. Okay, we can call this imaginary force lah. The actual force is this force, the green one. Okay, this is the actual force that she's pushing down. But how do you count the green one? You know, because it is saying here it is at an angle, so we count it now in relation to the horizontal and the vertical forces. Because it's 90 degrees, it makes it that much easier. Okay, and so the horizontal force, the horizontal force, okay, is calculated by F cos theta. Okay, and the vertical force, okay, is counted by F sin theta. I'm not going to waste time by going into kenapa cos, kenapa sin lah. But this is the most important thing. Okay, theta must touch the horizontal component. Okay, for this and this to work, okay, the angle of theta must be touching the horizontal component. Okay, so when we bring this into here, we find that 85 newtons equals to F cos 60 because it's horizontal. Okay, and so because of that, you can calculate lah, F equals to 85 over cos 60. And which will give you something much bigger, I think. 85 divided by cos 60. 170. Okay, so your answer will be D. Okay, so this question, it's not that difficult per se, tapi kalau kamu lupa sudah how do you resolve the forces, how to do the resolution of forces, itu yang menjadi susah lah. Okay, alright. Diagram 22 shows a graph of stretching force against extension. Both springs are made from the same material with the same thickness of wire. Okay, which statement is true about spring R and spring S? Okay, so R has a smaller force constant K than spring S. Okay, R has a smaller force constant than spring S is not true because the K, K is represented by the gradient of the graph, okay, of F against X. So if it is an F against X graph, the gradient will represent the value of the K, the spring constant, the kekerasan spring. So definitely you find that the R gradient is bigger, K is bigger, this one the K is smaller, so A is wrong. Spring R is stiffer than spring S. Okay, this will be correct lah, because the K, the spring constant, is also a measure of its stiffness. Okay, nothing to do with length and definitely nothing to do with the larger diameter of coil lah, because it is the same thickness, okay, it is the same length, everything, semua sama. Okay, so only the difference is the thickness. Sorry, the stiffness. Okay, 24, which modification enables the arrow to move farther when it is released? Okay, to reduce the spring constant of the spring, okay, is definitely wrong, because when you reduce the spring constant, the string becomes lebih lembut, okay, and it's, you know, you need it to be more tense lah, you need to be stiffer so that you can, you know, have a more bigger potential energy. Okay, the arrow is made from a stronger material is possible, okay, but not entirely true. When you compare to C, to increase the spring constant of the spring. Increasing the spring constant means you increase the stiffness. When you increase the stiffness, you have a bigger potential energy. You can store more energy because it is more stiff. Okay, higher density is definitely wrong because this will make it heavier lah. Okay, stronger material, as I said, is possible. Okay, they are possible but it doesn't really make a difference. If it is stronger material, if the arrow is made from stronger material, okay, but if the string still remains the same, it doesn't really make much of a difference. Okay, we want the arrow to move further, and all of it lies in the string, okay, and the GSIM of the arrow lah. Okay, the lighter, the less the GSIM, the less the mass, okay, the farther it can travel. So that's why we don't say high density. Stronger material for the arrow, nothing really, no, not a really contributing factor lah. Okay, shows a kid drinking a packet of milk. When he finished drinking the milk, the empty packet crumbled inwards. Okay, what caused this situation to happen? Okay, and if you remember, okay, so when you drink water from a straw, okay, or you drink anything from a straw lah, okay, what you're essentially doing is you're creating a vacuum, okay, and you're actually just, what you're doing is you're just sucking out all the air. What is actually pushing the water into your mouth is actually the pressure inside the box, or if it is a glass, it is the atmospheric pressure lah. Okay, so if you finish all the water and you continue, you know, sucking the straw, what's going to happen? The empty packet is going to crumble inwards because, okay, the atmospheric pressure is going to be bigger than the pressure inside the packet drink, because you're sucking out all the air. So when you're sucking out all the air, there's nothing to push the box, okay, untuk keluar. Okay, and so because there's nothing to push it, the atmospheric pressure is going to crumble it. Okay, so atmospheric pressure atmospheric pressure is one of those things that really remind us of how insignificant we are. Okay, of how insignificant we are as humans. We think that we are the ones that are so hebat lah. Like, you know, wow, okay, we are the ones that, you know, menyebabkan itu kotak air menjadi kemet. But actually, sorry lah, you're doing nothing. You're just sucking air out lah. Okay, so the only thing that is the real person that is actually working is the atmospheric pressure. Okay, so jangan juga kamu perasan diri hebat lah. Alright, this is 25, where's 26? Okay, 26 is this. Diagram 26 shows a submarine traveling in the sea of a level of 20 meters below the surface. Given the atmospheric pressure is 1 times 10 to the power of 5, density of seawater is this. What is the pressure exerted on the submarine in kilopascals? Okay, so we need to remember that anything that is under the water is subject to two pressures. Number one, the atmospheric pressure, and number two, the liquid pressure. Okay, so the total pressure on the submarine is the atmospheric pressure plus the liquid pressure. And the good news is atmospheric pressure is given. So 1 times 10 to the power of 5 plus liquid pressure is calculated by rho GH. Okay, rho GH, where H is the depth of the water. Okay, and then G is normal, and then rho is the density of the sea water. So we're talking about 1200 times 9.81 times 20 meters. Okay, and then you need to add it together. Now, a very common mistake is if people remember how to do this, okay, they will get about this one, 235.44 kilopascals. Okay, and then they will immediately circle the answer C, which is wrong. Okay, the answer is not C because that's just the liquid pressure. You haven't taken into account the atmospheric pressure. So kita kena tambah lagi 1/10⁵. Okay, and that will give you the actual answer, which is D. Notice that they will give you the alternative answer yang memang kamu boleh cari itu, kan? Quite a number of you actually answered C for this question, which I'm like, oh, okay, kena trick. Okay, be very careful lah. Quite a lot of you answered C. Then I was like, oh, okay, I guess they forgot to calculate the atmospheric pressure lah. Okay, so be aware of this, that anything that is on the earth is subject to atmospheric pressure. Okay, so yeah, be careful about it lah. All right. 27, floating objects P, Q, R, and S, which is the descending order for the density. Okay, so this is a very common trick question. Okay, the descending order means which is the highest density until which is the lowest density lah. Okay, and so we want to take a look at the percentage of it that is in the water. The more it is in the water, okay, the more dense it is. I repeat, the more it is in the water, the more dense it is. So we're talking about P, S, R, and then Q. Okay, the more it is in the water, the more dense it is. So P is mostly in the water, so this is very dense. Okay, there is not enough upthrust, upthrust to to push it up lah. Q is like sikit saja di bawah air ni kan. Look at the amount of it that is in the water. Kalau kita tengok dari segi peratus lah, we don't look at the size. Okay, we don't look at the size. We just look at how much of it is in the water. Okay, so PSRQ would be the only logical one. Okay, actually, if you ask me, when I was doing this question, it looked like dia nampak macam S lebih tinggi. It looks like S has more in the water compared to P. But there was no answer option over here lah. So I just chose the next place on which was A lah. Okay, 27 will be A, P, S, R, and Q. But again, the key to answering this is how much of it is in the water, regardless of the size. Okay, regardless of the size. Just remember, buoyant force is equals to rho GV. Okay, the bigger your buoyant force, the bigger this one is in the water, the bigger your buoyant force will be. Okay, so this one has more buoyant force. Okay, because of the high density. All right, 28. Buoyant force acting on the balloon is equals to, and so buoyant force F equals to rho GV. Okay, of course, number one is the weight of the air displaced by the balloon. That's Archimedes' principle. Okay, that's Archimedes' principle, and that's very normal. Okay, and definitely also dependent on, will be equal to the weight of the balloon. If it is floating in the air, okay, the weight will be equal to the buoyant force. So dia tidak bergerak ke atas dan ke bawah, dia stable. Okay, if it is going up, if the balloon is going upwards, means the buoyant force is bigger than the weight. If it is going down, means the weight is bigger than the buoyant force. But since it is at a fixed height, dia tidak bergerak ke atas, dia tidak bergerak ke bawah, it is floating. And since something is floating, so the buoyant force must be equal to the weight of the balloon and the weight of the air displaced by the balloon. That's by Archimedes' principle. Nothing to do with the density of the balloon. Okay, really nothing to do with the density of the balloon. It is a factor that affects, but it is not equal to the density of the balloon. So the answer will be 1 and 3. This one, quite a lot of you got it correct, so that's quite good. All right, 5 different resistors, okay, are connected in series. Which statement is correct? Okay, and so series circuit is series is like this lah. Okay, dia bersambung secara terus. Okay, so you can think of resistors as 5 different light bulbs. 5 mentol yang, yang sama, 5 different resistors, so it's 5 different light bulbs, but they're all connected in series. Okay, so which statement is correct? The potential difference across the resistor is the same. This is wrong. In a series, okay, it is the current that is passing through the resistor is the same. Okay, ini adalah fakta lah. Okay, not to say benda untuk difahami atau ini, tapi the fakta is there. Okay, the power dissipated by each resistor is not the same because the potential difference is different. Okay, the effective resistance is smaller than individual resistance is also wrong because the effective resistance juga dikenali sebagai the total resistance. For series circuit is campur semua. So definitely cannot be smaller than the individual resistance. Okay, rintangan berkesan memang lebih besar daripada rintangan setiap satu perintang secara individu. So the answer will be C. Okay, which circuit can be used to determine the electromotive force of a dry cell? Okay, electromotive force, this is subtopic 2.3, I think. No, 3.3. Okay, it should be 3.3. Yeah. Now, electromotive force, you need to know that the voltmeter is arranged parallel to the battery. So this will be the answer. Okay, this is definitely out. You'll never put an ammeter disambung secara siri. Okay, kepada selari kepada battery. This is also out. This is definitely out lah. Apa ini? Ini salah ini ya. Okay, so another common answer which will be given to you is this lah. Okay, you have the ammeter over here. You have the light bulb. Okay, and then here is the voltmeter. So this and these are the 2 most common ones. But this one, okay, is the setup for Ohm's law. Okay, and this is the setup for electromotive force. We need to be very clear about this. There's only one difference, where the voltmeter is parallel to. In the electromotive force of a dry cell, okay, then you need to put the voltmeter with the dry cell. Ohm's law is the resistance of the light bulb or the resistance of the the resistor. So you put the voltmeter parallel to the light bulb or the resistor. Okay, that is for Ohm's law. Because even the graph is different. For electromotive force, the graph V against I is like this. Okay, manakala Ohm's law, the graph, okay, V against I is a directly proportional graph. Simply because of where the voltmeter is placed. Okay, tempat di mana voltmeter itu diletakkan. So that's a very important distinction that I hope that you know lah. Okay, if you don't know, please remember this. Okay, charge flows in the electric circuit in 3 minutes is 9 coulomb. Okay, what is the current? Q equals to IT. Okay, Okay, so you want the current. The charge flow is 9. I is what you want to count. And then the time is 3 minutes, but you need to change it to seconds. Okay, so 3 minit diubah pergi seconds is 180. And you will get the answer 0.05 amps. I think so. Hold on, 9 divided by 180. Yeah, 0.05 amps. Okay, this formula again is given to you at the first page lah. Okay, Q equals to IT. This is subtopic 3.1. If I'm not mistaken lah. I hope I got my chapters correct. Should be lah, should be. Okay, coming down to the final stretch. Oh, sorry. So again, the same thing. Question 21 until 30. 21 until 30, unfortunately, is chapter 1, chapter 2, and a little bit of chapter 3 lah. Okay, and I noticed that this is the section where most people get it wrong. Yeah, in both classes. Both 5SA and 5ST have problems in this section. The two biggest sections which are the biggest problems is 11 to 20, which is heat, wave, and light. Okay, which I understand now. Well, actually, at least for those in 5SA, we had a lot of problems with heat last year. Like everybody cannot answer heat for some reason. So 11 to 20 was expected. Saya memang menjangkakan bahawa okay, ramai akan menghadapi masalah 11 to 20 sebab heat and light. These are two chapters which a lot of Form 4 students don't like. Okay, but I'm very surprised with this chapter. I'm very surprised with this section. Ramai yang 21 until 30 also is problematic. Quite a lot of people, they lost a lot of marks in the 21 to 30 section, which is especially this one now. You know, the certain few questions. This one was a very commonly wrong asked question. This one also another one because diorang salah ini. Okay, yeah. Okay, generally those two lah, but of course there were some people that totally got the entire section wrong lah. Okay, so again, just to remind you, breaking it up into sections helps you to know which chapters you should focus on first. Okay, in your whatever study plan that you have lah. Okay, for physics. All right, let's continue. 32. Okay, diagram 32 shows a heating element with a resistance, yada yada. What is the power generated by the kettle when it is connected to a 240 volt power supply? You are only given the resistance. So this is either you don't remember or you remember lah. Okay, let me go. Let me go to the page. Page 2. Okay, so the power formula is only this. This is the only formula for power given. Okay, but if you combine this and this, okay, you can actually come up with the other two formulas, which is P equals to I squared R and P equals to V squared over R. Kita gabungkan this formula and this formula. Okay, that's why they will only give you one power formula. They won't give you all three because it doesn't make sense. Same like energy. Okay, if you already know the power, you know that you can count the energy. Energy is VI over T. Okay, or energy is, okay, so on and so forth lah. Okay, so yes, do not expect do not expect these formulas to come out. Okay, you again as I said lah, tiada guna kalau itu formula ada tapi kau tidak tahu macam mana mau pakai. You need to know that they're not going to give you everything under the sun, They're not going to give you what is important. You should be able to derive the rest. Okay, so power equals to IV, you combine these two and you can get P equals to V squared over R, which will bring us to that question. Oh dear. Okay, so we have R and we have V squared. The power equals to V squared over R is 240 squared divided by 20, which will give you the answer of B, 2880. 240 squared divided by 20. Yeah, 2880 watts. It's a very simple calculation question, bahkan really nothing to it, But again, as I said, if you don't know the formula, if you don't know how to derive the formula, No matter how simple I put the question pun kan, kamu yang akan cakap susah soalan. Sebenarnya tidak. Okay, yang susah itu adalah kamu tidak menghafal macam mana mau derive the formula. Itu yang susah. So who can help you from that kesusahan? Of course you yourself. Okay, I can only carry you so far. Yang akan mengambil exam at the end of the day is you. Okay, so you should not blame other people or other things lah. Oh, ni senarai formula tidak lengkap ini. It's not your fault. It's not their fault. It is lengkap. For me, it's lengkap. Sebab saya boleh terbitkan yang lain. Okay, daripada itu. Alright. 33. Okay, diagram shows a simple direct current electromotor. When the switch is turned on, it results as a catapult field and turns the coil. Okay, we need to think about this. Motor is left hand or right hand? Okay, obviously it's left hand because right hand is to determine the current. It is generator. Left hand is motor. You all did videos on this. Okay, dengan itu buku. Oh, sorry, not you all. Okay, whoever did the videos on this, you would be able to remember, hopefully, okay, that the motor involves the left hand. Okay, so we'll need to talk about left hand. So the current is flowing this way, going this way, and coming out this way. So you can determine the direction of this one. Okay, so if you use the left hand, north to south is here, current is going in, you know that this one is going to go down and this side is going to go up. Okay, let me redraw this again. This side is going to go downwards and this side is going to go upwards. Hold on, let me just double check. Yeah. Okay, so yang kiri akan pergi ke bawah, yang kanan akan pergi ke atas. So there's only two options, either this or this. And so this one is definitely out. Okay. Now, when we look at the catapult field, okay, when we look at the catapult field, you need to remember the catapult field nanti adalah dalam bahasa Melayu dipanggil sebagai medan lastik. So kalau ini adalah batu, okay, dan kamu mau batu itu pergi ke sebelah sini bahkan, it doesn't make sense that the elastic is this way, right? Kau mesti tarik ke belakang dan lepaskan, baru dia akan poyong ke depan. Kan? So the elastic should be here. Because ini seperti kamu tarik ke belakang supaya this batu boleh terhumban ke depan. That is how I remember the elastic field, the catapult field. Okay, elastic itu mesti berarah bertentangan dengan, the arah gerakan itu. Okay, so the answer will be D. Okay. Of course, the key to answering this is the left-hand Fleming rule, okay, which you should master, especially those of you who did the video. If you didn't do the video, then it's on you lah. But if you did the video, then I hope that you remembered it. Okay, diagram 34 shows a coil of wire placed next to a magnet. The galvanometer pointer deflects. Okay, when the magnet is pushed in the coil. So which action will increase the deflection of the galvanometer pointer? Okay, a little bit of revision. Increasing the deflection of the galvanometer is Faradays Law. Faradays Law. Okay, how to increase the deflection. So magnetic pole is reversed, totally nothing. It's not going to increase the deflection. Number of coils is increased is the correct answer. Okay, the coil is made from insulated wire, lagi lah tidak boleh. If the wire is insulated, kan lagi susah. Okay, and actually it has nothing to do with this one. Okay, and of course the last one, the magnet is pushed slowly into the coil, memang out. Okay, the relative motion, okay, or the cutting of the magnetic flux, okay, has to be much bigger, and you do it much bigger by pushing it much faster, okay, in and out of the coil. All right, so this is Faraday's law. Okay, Rosman charges his notebook computer using a battery charger. The charger has a transformer as shown in diagram 35. Okay, so over here you have this. Okay, it's a very big transformer, although it's a small transformer like inside the notebook. Okay, that changes 240 volts to 20. Okay, primary coil is 12,000. So you're going to ask, what is the secondary coil? Of course, we are expecting a step down transformer. It's a very important thing. So step down transformer, all transformer formulas should be found also in the first page. Let's go back to the page. Transformer, Nina. Okay, NS over NP equals to VS over VP. Again, having the formula list is useful, but if you don't know how to use the formula list, ... Okay, so NS over NP equals to VS over VP. Okay, so NS is what we want to find, the number of turns in the secondary coil. NP is 12,000 equals to 20 over 240. Okay, and when you calculate this, you should be able to get the answer C. C kah? 3 over 240 times 12,000. Oh yeah, okay, C. Okay, 1,000 turns in order for you to be able to get 20 volts. Okay. So, I'm going to leave my comments until the end. Okay, transmission of electricity, transformer P. Okay, once it comes out from the power station, it has to be stepped up. Okay, so we're talking about step-up transformer. So what is the use of the step-up transformer? It is to increase the potential difference. You don't talk about increasing the current. A lot ni salah ni. Okay, remember, you increase the potential difference to decrease the current, because a smaller current flow, okay, will decrease the power loss. Okay, power loss dikira sebagai I squared times R. Okay, resistance of cable can't really change because their cable adalah tetap sudahlah. What you can change is the voltage or the current. So you increase the voltage to decrease the current so that there is less power loss. All right, sounds like Christmas in my house, but yes. Diagram 37 shows the process of electrons escaping from the surface of a heated metal. Okay, so the name of this process is thermionic emission. Ini tahu atau tidak tahu? That's it. There is no like apa ini, okay? But actually, if you think about it, guys, you have not even touched any of these three other things. What is electron induction? Wow, no, you have not learned it. Molecule ionization, we have not even learned it. At least in physics lah. You may have learned it in chemistry, I'm not sure. But in physics, we only look at molecule ionization in chapter 6. And itu pun kan touch and go saja. We don't even go in depth into it. Infrared emission. No. We don't even talk about this. This may be in chapter 7 lah. Okay. But we haven't even started talking about this. The only one that makes sense is this. Okay, thermionic emission. So again, this is a kind of question where it's either kamu tahu atau kamu tidak tahu. And if you don't know, then that's where the weakness lies lah. Okay. In a cathode ray tube, maximum kinetic energy is this, 1.32 times 10 to the power negative 15. What is the potential difference? Okay, we need to remember that in a cathode ray tube, and this is a very important formula, the kinetic energy, half mv squared equals to electrons times the voltage. Okay, half mv squared equals to EV. So, the kinetic energy is already given. 1.32 darab 10 kuasa negatif 15 equals to... equals to EV. 1.6 times 10 to the power negative 19 times V. Okay, so 1.32 times 10 to the power negative 15 divided by 1.6 times 10 to the power negative 19. So, it will be 8250. Okay. Why do they give the mass? Tapi kita tidak pakai. Sudahlah, saya type salah ni kan. Apa ini? Sorry. Okay. So why do they give the mass when you're not even going to use it? Actually, the question that you should be asking is, why are you asking this question? So what if they give you the mass? Yes, it's supposed to help you. The information that is given in the question is supposed to help you lah. But it's not supposed to blindly help you lah. Like, some of you got this wrong, I suspect, because you wanted to put this M inside. Mati-mati saya mau kasih masuk ini M di dalam. Like, okay, if you don't know, then okay. Come back to the formula again. Is the formula given or not? La la la. Wow, it is given. Electric potential energy. And wow, it also is given. kinetic energy equals to the electric potential energy in a cathode ray tube, okay, in a sinar cathode lah. So half mv squared equals to E times V. Okay. The formula again, guys, the formula is given, okay, but yang susah adalah orang yang tidak tahu macam mana mau pakai lah, okay, itu yang susah. And this is even better, no? The question already gave you the value of the kinetic energy. You don't even need to calculate this. Okay, normal questions in paper 1 and in paper 2, they will ask you to count the kinetic energy and then they will ask you to count the potential difference. Okay, so yes, please take note of it. Okay, so yeah, so why is the mess there? Okay, rectification of an alternating current, the existence of a capacitor will tell us that kalau ini saja, then it will be this lah. Kan? But the existence of the capacitor will tell us that this is the graph that we're looking at. Okay, it will be D. Definitely. This is half wave. Okay, this is full wave. This one is half wave plus capacitor. This is full wave plus capacitor. Okay, this is a full wave rectification circuit. Half wave is just one diode only. Okay, so like that lah. Okay, this is a half wave rectification circuit. So if I put the CRO over here, okay, CRO, okay, this is a half wave rectification circuit. Okay, if I want a full wave, if I want a half wave with capacitor, so I put the capacitor parallel to the resistor lah, macam ni lah. Then I will get this. Okay, this B answer. But this is not the answer for this question. The answer is G. Okay. All right. Last question. Transistor. Okay. Transistor circuit shows turn on a 240 volts air conditioner. Which condition can turn on the air conditioner? Okay, which condition can turn on the air conditioner? The thermistor temperature is low. Okay, this one logic also will tell you that if the temperature is low, why do you want to turn on the air conditioner, Bakan? For what? Why would you want to turn on the air conditioner if the thermistor temperature is low? Kan? Doesn't make sense at all. Orang mau pasang aircon bahkan ketika suhu tinggi. Jangan juga kemudian ya. So it's 2. Okay, suhu dia adalah tinggi. The base voltage is high or the base voltage is low. Definitely the base voltage must be high. Okay, I spent a very long time talking about this. I said this is the base voltage. Okay, this is the base circuit. The base voltage must be high so that the transistor can switch on. Transistor can switch on, then the air conditioner will turn on. If the base voltage is low, then the transistor will switch off. Okay, which cannot happen lah. Okay, so the only answer for this is C. Quite a lot of you answered A for this. So I'm glad that you understood that high base voltage is correct. But ayo guys, low thermistor temperature. Okay, low thermistor temperature means cannot be what. Okay, so yeah. Okay, so be careful about this. Okay, high voltage, high base voltage and high thermistor temperature. Because when it's high thermistor temperature, then the resistance will be low. Sini resistance low, sini resistance high, base voltage will be faster. Okay. So after discussing all these questions, good, at least I still have 5 minutes to say what I want to say. Okay, after discussing all these questions, okay, you can put your marks over 40. Okay, I'm still marking on paper 2, by the way. But I will start discussing paper 2 with 5SA in my afternoon class with them today and also tomorrow morning. So you guys can watch the paper 2 videos at your own time. Okay, I won't repeat the lesson. And because I want to get this discussion, habis secepat mungkin. So yeah, so there's no double lah. Kan biasanya, contohnya lah, biasanya macam kelas sekarang kan, then in the afternoon 5SA I will just ask them to watch the video of our class today. But because this is only a discussion and it's not me teaching, okay, so I don't really see a point in, in wasting time. So this afternoon, I will discuss paper 2 with SA, and also tomorrow morning when I have class with them. And you guys can watch the paper 2 video if you want from there. Okay, to see your answers, check your answers, see where it's correct. Okay, you can watch it at your own time. It's totally no problem. You're not obligated to watch lah. Dia bukan wajib. Tapi kalau kamu mau tahu kamu punya kedudukan or at least where you can improve, this is where you should watch the video lah.